Good to go.
Okay, this is the final project demonstration of the Arduino implementation of the C code for the smart pool with for temperature regulation. And now I am Marcel Castro with Angel Saz, and I'm going to show my code, which I implemented here in Arduino. Uh, now the code is running. Is the sensors. I'm using a DHT22 sensor for humidity and temperature. Basically, what this code does is to censor the temperature and the humidity, and then after that in the code, it makes a decision of to start the water heater pump, the water heater mechanism system to heat the pool water or the water in the household, or if the temperature, ambient temperature is below some threshold, like for example, if the ambient temperature is below 18 Celsius degrees, then it starts the water heater, the heating water mechanism. And if the ambient temperature is above that threshold, like 18 Celsius degrees, it deactivates the mechanism, so it don't heat the water. It doesn't heat the water. So for here, it's working right now. You see, it's reading the data. A temperature 21 degrees, humidity 47, temperature 21, the heat index 9. All that data is sent to a platform for IoT platform named Losant. Here's right here. Where is Losant? Losant is here. Right here, which is a platform for IoT devices, like DHT sensors and the ESP8266 board. It is reading the temperature in Fahrenheit, 70 degrees, and the humidity is 46. It's continuously measuring the values sent from the sensor. See, okay. And now I'm going to the C code, my Arduino. I'm gonna show the whole program first, and then I'm going explaining uh, what does the code for, summarize, summarize what the code is doing, right? Here's the includes for the libraries for the board ESP8266, those two for the connection to the Wi-Fi, for the platform Lawson, for IoT platform Lawson, for the sensor DHT, the library for the sensor, the pins that are connected to the board. These are the pins that the board uses to send the data. This is my Wi-Fi ID and the password for connecting to for my internet connection here at my home at the Wi-Fi. This is a function connect, which connect to the Losant IoT platform. This is what is doing this function right here. First, it creates a device, an object from Losant device, and then the function connect. It connects, with my Wi-Fi password and user ID. Okay, all that is right here. Okay, so all this is the connect function. This is the setup to start transmitting data here at the Arduino. Serial begin. This is the baud rate that it uses. Device started. the setup function. This is the swimming pool water heater function. What I was talking about, that you get a temperature value, and then you have a threshold, a low threshold like 18 degrees Celsius degrees, and a high threshold 25 Celsius degrees. If that temperature from the ambient temperature that we have outside is below the threshold, so it's colder, right? It's cold, right? So it turns in with digital write. It turns on the water heater mechanism, the system, with this function right here, digital write, pumping, and high. It turns on the mechanism, the system. Here, swimming pool water heaters, pump activator, and heating the pool water. So if the temperature is above that high threshold, that is 25, we can modify these values as if we want. If the temperature is above the high threshold, so it turns the digital right, it turns the system to low, so it turns off the system. So swimming pool water heater pump deactivated and not heating the pool water. Okay. So now it's just like a main function, like a loop function. What it does is connecting, and if it's not connected, to reconnect, it tries to reconnect it again until it connects. Okay. This is all my code here. Then it reads all the values from humidity here, float H, DHT get humidity, float T, DHT get temperature, float F, DHT to Fahrenheit. Check if any reads fail and exit early. If there are some problems with the DHT sensor, like doesn't read the values from the sensor, it send then a print statement that failed to read from DHT sensor. And then it prints here, is what we're seeing here. Serial print humidity and the value, temperature with the value in Celsius as in Fahrenheit, then the heat index, and then the in Celsius in Fahrenheit. Okay. I can explain a little better the code. I have it here. This Arduino C program is designed for an ESP8266 microcontroller to monitor environmental conditions, temperature, and humidity using a DHT22 sensor and transmit the data to Lawson IoT platform. Here's a breakdown of the code. The libraries, they include the ESP8266 Wi-Fi.h, the ESP8266 EHT PVC client, the Wi-Fi client for the Wi-Fi connection, all these libraries, the Lawson library, the DHTF.h, okay? This handles Wi-Fi connectivity, provides HTTP functionality to communicate with web services. Wi-Fi client manages client-side network communication. Lawson is a library for connecting the Lawson IoT platform. DHTS, library for interfacing with the DHT22 temperature and humidity sensor. Then definitions and configuration, define DHT pin 14, define DHT type DHT22, DHTF, DHT. DHT pin specify GPIO 14, D3 pin for the sensor connection. This is all for the connection of the sensor, for the DHT22. DHT type says the sensor type as DHT22. DHT is an object used to interact with the DHT sensor. Wi-Fi and Lawson credentials. Concierge Wi-Fi SSID. This is the name of my Wi-Fi here at home, and this is the password. So I created two variables, like character strings for these two values, name Wi-Fi SSID and Wi-Fi pass. Okay. Connecting to Wi-Fi and Lawson connect function. This is the connect function. It handles Wi-Fi connection, initializes and connects to the specified Wi-Fi network, retries for 5 seconds before timing out, outputs connection status via the serial monitor. Okay. Lawson authentication sends an HTTP post request to the Lawson's API for device authentication, uses a Lawson access key, secret, and device ID, prints success or error messages to the serial monitor. MQTT connection establishes an MQTT connection with Lawson, waits until the device is connected before proceeding. The setup function. The setup function, serial begin 115200. This is baud rate for serial communication. DHT setup and connect. Configures the serial monitor for debugging. Sets up the DHT sensor and establishes initial connections. Sensor data reporting. Report function sends a JSON payload containing environmental data to Lucent. Humidity, temperature, Celsius and Fahrenheit, and heat indices. Uses the Lucent send_state function. The main loop. This is the code here, void loop. Monitors Wi-Fi and Lucent connection status. Reads sensors data every 5 seconds. This is a 5 second here in milliseconds. 5,000 milliseconds, 5 seconds. You know? Reads sensors data every 5 seconds. We can adjust this like the time we want, 10 seconds, 30 seconds, 1 minute, the time we want. Humidity, temperature, Celsius and Fahrenheit, and heat indices. This is what it reads with the DHT sensor. Validates the readings. Reports data to Lucent via report. Key features: Wi-Fi connectivity. The ESP8266 connects to the internet using provided SSID and password. Sensor integration. Reads temperature and humidity from DHT22 sensor. Lucent IoT platform authenticates and reports environmental data to the cloud. Error handling. Validates Wi-Fi credentials, Lucent authentication, and sensor readings. This program allows real-time monitoring of environmental conditions via the Lucent platform, making it suitable for IoT projects. Okay, so we are back to the code here. It's still reading the temperature and humidity. Humidity, temperature, heat index in Celsius and in Fahrenheit. Okay, I will do another compilation. Let's see. We can check it runs perfectly. Okay. We are compiling and running the program from the beginning. It's here, done compiling and uploading. It compiled very well. This is the Arduino IDE platform. Okay. Connecting to the Wi-Fi. So it's connected now. Wi-Fi connected, IP address, authenticating device. This device is authorized. Connecting to Lucent, connected. This device is now ready for use and now starts reading. Okay. So I started off from the beginning, from scratch, and it's working perfectly. It's reading the sensor, the DHT22 sensor is reading, and it's working up properly, and it's sending data right here. We are going to the Lucent platform, and it's right here. This is the Lucent platform for IoT devices. Device here. This is the board ESP8266. Okay. It's receiving the temperature in Celsius degrees, in Fahrenheit degrees, and humidity, the heat index in Fahrenheit, the heat index in Celsius. Right here. You can see here, it's receiving the data. from the sensor. So that's it. That's the program right here working. So the main thing is that the sensor reads the data, the temperature and humidity, and then it makes a decision. With this function right here, it receives the temperature in Celsius degrees. Then if the temperature is below the threshold, it turns on the heating system. It turns the it turns the heating system to high. Swimming pool water heater pump activated and heating the pool water and the water in general. Else if the temperature is above the high threshold, it turns off the heating system. It turns it to low. Swimming pool water heater pump deactivated and not heating the pool water. So that's the heating mechanism. So that's it. That's the code, the program, and you could see that it's working perfectly. So that's it. Thank you very much. That's my project with Angel Sass, and
Yep.
thank you.
Thank you very much.
So